Video is on what the heck is a function. So a function is a mathematical relationship between an input and an output where the input has only one output. So if you put something in, it's only going to go to one other number or one other thing. One of my favorite examples of a function is actually, if you think about a grocery store, each item has only one price. So if I'm buying a gallon of milk and a bag of potatoes, the milk and the potatoes are going to ring up at they each have their own price. That price might be the same. So there's no rule about functions that the output can't be the same for two different inputs. But when I swipe the milk, it's not going to appear at $3.99 and $2.79. It's only going to have one price. So for each input, there's only one output. Another more mathy example of a function is y equals 3x plus 2. So if we make a table here with x and y, and I just pick some numbers for x, 0, 2, -1, each one of those inputs only has one output. So if I plug in 0 for x, this is 3 times 0, which is 0 plus 2. If I plug in 2 for x, 3 times 2 is 6, plus 2 is 8. And -1, the output would be -1. No, it wouldn't. I could do math. Yes, it would. All right, another way to write this function is to write it as f of x equals 3x plus 2. So one way to represent that is, instead of saying find y when x equals 0, I could simply write f of 0 equals 2. So this is our input and this is our output. I could also write f of 2 equals 8 and f of -1 equals -1. This is not saying that this is f times 2 or f times 0. It's a function notation, has the input with the function right there. So this is a function f. It doesn't have to be f. It could also be the function g, or the function h, or the function a of w. Another example of a function is a graph. So if we were looking at a graph of a parabola, which looks like this is a function, because I know that for each one of these inputs, each one of these x values, there's only one corresponding y value. So an input right here corresponds to an output right there. An input over here corresponds to an output up here. A circle is not a function. And the reason why is because if we looked at an input, a given input, it actually would have two outputs. If I plugged in 2 for x, there would be an output up here and down here. And I'm making up numbers. Let me not do the number 2. But for this x value, there would be 2 y values. That means this is not a function. Let's do some problems where we're looking at the graph and judging if something is a function. There's a handy test that we can use. It's called the vertical line test. And the vertical line means that we're just going to take a vertical line and pass it over the graph. If it hits one spot only as it's going through, or one spot at a time, it is a function. If it hits more than one spot, it's not a function. So for here, if I'm passing my vertical line through, I can see it's only hitting one dot at a time. That means that yes, this is a function. For the second graph, as I pass my vertical line through, I can see that it hits more than one spot. This is not a function. This one, not a function. This one, not a function. This one is a function. This one is a little tricky, but looking at all of these, so far, so good. And then right there, we're hitting, if I can draw a line. Nope, I'm not going to be able to draw that straight line. It hits more than one point at once. This is not a function. Hopefully, this helps you judge what is a function and what is not.